Andrew Huberman, and I'm a professor of neurobiology and ophthalmology at Stanford School of Medicine. For today's podcast, we're going to talk about the parts list of the nervous system. Now, that might sound boring, but these are the bits and pieces that together make up everything about your experience of life, from what you think about to what you feel, what you imagine, and what you accomplish from the day you're born until the day you die. By the end of this podcast, I promise you're going to understand a lot more about how you work and how to apply that knowledge. So let's talk about the nervous system. The reason I say your nervous system and not your brain is because your brain is actually just one piece of this larger, more important thing, frankly, that we call the nervous system. The nervous system includes your brain and your spinal cord, but also all the connections between your brain and your spinal cord and the organs of your body. It also includes, very importantly, all the connections between your organs back to your spinal cord and brain. So the way to think about how you function at every level, from the moment you're born until the day you die, everything you think and remember and feel and imagine, is that your nervous system is this continuous loop of communication between the brain, spinal cord, and body spinal cord, and brain. In fact, we really can't even separate them. It's one continuous loop. The way to think about how the nervous system works is that our experiences, our memories, everything is sort of like the keys on a piano being played in a particular order, right? If I play the keys on a piano in a particular order and with a particular intensity, that's a given song. We could make that analogous to a given experience. Our brain is really a map of our experience. We come into the world and our brain has a kind of bias towards learning particular kinds of things. It's ready to receive information and learn that information, but the brain is really a map of experience. So let's talk about what experience really is. What does it mean for your brain to work? Well, I think it's fair to say that the nervous system really does 5 things, maybe 6. The first one is sensation. Sensation is a non-negotiable element of your nervous system. You have neurons in your eye that perceive certain colors of light and certain directions of movement. You have neurons in your skin that perceive particular kinds of touch, like light touch or firm touch or painful touch. You have neurons in your ears that perceive certain sounds. Your entire experience of life is sort of filtered by these, what we call sensory receptors, if you want to know what the name is. Perception is our ability to take what we're sensing and focus on it and make sense of it, to explore it, to remember it. So really, perceptions are just whichever sensations we happen to be paying attention to at any moment. Perception is under the control of your attention. And the way to think about attention is it's like a spotlight. Except it's not one spotlight. You actually have 2 attentional spotlights. Anyone that tells you you can't multitask, tell them they're wrong. And if they disagree with you, tell them to contact me. Because in old world primates, of which humans are, we are able to do what's called covert attention. We can place a spotlight of attention on something, for instance, something we're reading or looking at, or someone that we're listening to, and we can place a second spotlight of attention on something we're eating and how it tastes, or our child running around in the room, or my dog. You can split your attention into 2 locations, but of course you can also bring your attention, that is your perception, to one particular location. You can dilate your attention, kind of like making a spotlight more diffuse, or you can make it more concentrated. This is very important to understand if you're going to think about tools to improve your nervous system. Attention is something that is absolutely under your control. The nervous system can be reflexive in its action, or it can be deliberate. Deliberate thoughts are top down. They require some effort and some focus, but that's the point. You can decide to focus your behavior in any way you want, but it will always feel like it requires some effort and some strain, whereas when you're in reflexive mode, just walking and talking and eating and doing your thing, it's going to feel very easy. And that's because your nervous system basically wired up to be able to do most things easily without much metabolic demand, without consuming much energy. But the moment you try and do something very specific, you're going to feel a sort of mental friction. It's going to be challenging. So we've got sensations, perceptions, and then we've got things that we call feelings/emotions. And these get a little complicated because almost all of us, I would hope all of us, are familiar with things like happiness and sadness or boredom or frustration. Certainly, emotions and feelings are the product of the nervous system. They involve the activity of neurons. But as I mentioned earlier, neurons are electrically active, but they also release chemicals. And there's a certain category of chemicals that has a very profound influence on our emotional states. They're called neuromodulators. And those neuromodulators have names that probably you've heard of before, things like dopamine and serotonin and acetylcholine, epinephrine. Neuromodulators are really interesting because they bias which neurons are likely to be active and which ones are likely to be inactive. A simple way to think about neuromodulators is they are sort of like playlists that you would have on any kind of device where you're going to play particular categories of music. So for instance, dopamine, which is often discussed as the molecule of reward or joy, is involved in reward, and it does tend to create a sort of upbeat mood when released in appropriate amounts in the brain. But the reason it does that is because it makes certain neurons and neural circuits, as we call them, more active and others less active. Okay, so serotonin, for instance, is a molecule that when released tends to make us feel really good with what we have, our sort of internal landscape and the resources that we have, whereas dopamine, more than being a molecule of reward, is really more a molecule of motivation toward things that are outside us and that we want to pursue. And we can look at healthy conditions or situations like being in pursuit of a goal where every time we accomplish something en route to that goal, a little bit of dopamine is released and we feel more motivation. That happens. We can also look at the extreme example of something like mania, where somebody is so, relentlessly in pursuit of external things like money and relationships that they're sort of in this delusional state of thinking that they have the resources that they need in order to pursue all these things when in fact they don't. I want to emphasize also that emotions are something that we generally feel are not under our control. We feel like they kind of geyser up within us and they just kind of happen to us. And that's because they are somewhat reflexive. We don't really set out with a deliberate thought to be happy or deliberate thought to be sad. We tend to experience them in kind of a passive, reflexive way. And that brings us to the next thing, which are thoughts. Thoughts are really interesting because in many ways they're like perceptions, except that they draw on not just what's happening in the present, but also things we remember from the past and things that we anticipate about the future. The other thing about thoughts that's really interesting is that thoughts can be both reflexive, they can just be occurring all the time, sort of like pop-up windows on a poorly filtered web browser, or they can be deliberate. We can decide to have a thought. And a lot of people don't understand or at least appreciate that the thought patterns and the neural circuits that underlie thoughts can actually be controlled in this deliberate way. And then finally, there are actions. Actions or behaviors are perhaps the most important aspect to our nervous system because, first of all, our behaviors are actually the only thing that are going to create any fossil record of our existence. After we die, the nervous system deteriorates, our skeleton will remain, but it's, in the moment of experiencing something very joyful or something very sad, it can feel so all-encompassing that we actually think that it has some meaning beyond that moment. But actually, for humans, and I think for all species, the sensations, the perceptions, and the thoughts and the feelings that we have in our lifespan, none of that is actually carried forward except the ones that we take and we convert into actions such as writing, actions such as words, actions such as engineering new things. And so the fossil record of our species and of each one of us is really through action. And that in part is why so much of our nervous system is devoted to converting sensation, perceptions, feelings, and thoughts into actions. The other way to think about it is that one of the reasons that our central nervous system, our brain and spinal cord, include this stuff in our skull, but also connect so heavily to the body is because most everything that we experience, including our thoughts and feelings, was really designed to either impact our behavior or not. And the fact that thoughts allow us to reach into the past and anticipate the future and not just experience what's happening in the moment gave rise to an incredible capacity for us to engage in behaviors that are not just for the moment. They're based on things that we know from the past and that we would like to see in the future. And this aspect to our nervous system of creating movement occurs through some very simple pathways. The reflexive pathway basically includes areas of the brainstem we call central pattern generators. When you walk, provided you already know how to walk, you are basically walking because you have these central pattern generators, groups of neurons that generate right foot, left foot kind of movement. However, when you decide to move in a particular deliberate way that requires a little more attention, you start to engage areas of your brain for top-down processing, where your forebrain works from the top down to control those central pattern generators, so that maybe it's right foot, left foot, right foot, left foot, if maybe you're hiking along some rocks or something and you have to engage in that kind of movement. So movement is just like thoughts, can be either reflexive or deliberate. And when we talk about deliberate, I want to be very specific about how your brain works in the deliberate way, because it gives rise to a very important feature of the nervous system that we're going to talk about next, which is your ability to change your nervous system. And what I'd like to center on for a second is this notion of what does it mean for the nervous system to do something deliberately? Well, when you do something deliberately, you pay attention, you are bringing your perception to an analysis of three things: duration, how long something is going to take or should be done; path, what you should be doing; and outcome. If you do something for a given length of time, what's going to happen? Now, when you're walking down the street or you're eating or you're just talking reflexively, you're not doing this, what I call DPO, duration, path, outcome, type of deliberate function in your brain and nervous system. Let's give an example where perhaps somebody says something that's triggering to you. You don't like it, and you know you shouldn't respond. You feel like, oh, I shouldn't respond. You're actively suppressing your behavior through top-down processing. Your forebrain is actually preventing you from saying the thing that you know you shouldn't say, or that maybe you should wait to say or say in a different form. This feels like agitation and stress because you're actually suppressing a circuit. We actually can see examples of what happens when you're not doing this well. Some of the examples come from children. If you look at young children, they don't have the forebrain circuitry to engage in this top-down processing until they reach age 22, even 25. But in young children, you see this in a really robust way. A kid sees a piece of candy that it wants and will just reach out and grab it, whereas an adult probably would ask if they could have a piece or wait until they were offered a piece in most cases. People that have damage to the certain areas of the frontal lobes don't have this kind of restriction. They'll just blurt things out. They'll just say things. Impulsivity is a lack of top-down control, a lack of top-down processing. So a lot of the motor system is designed to just work in a reflexive way. And then when we decide we want to learn something or do something or not do something, we have to engage in this top-down restriction. And it feels like agitation because it's accompanied by the release of a neuromodulator called norepinephrine, which in the body we call adrenaline, and it actually makes us feel agitated. So for those of you that are trying to learn something new or to learn to suppress your responses or be more deliberate and careful in your responses, that is going to feel challenging for a particular reason. It's going to feel challenging because the chemicals in your body that are released in association with that effort are designed to make you feel kind of agitated. And so this is really important to understand, because if you want to understand neuroplasticity, you want to understand how to shape your behavior, how to shape your thinking, how to change how you're able to perform in any context. The most important thing to understand is that it requires top-down processing. It requires this feeling of agitation. In fact, I would say that agitation and strain is the entry point to neuroplasticity. So let's take a look at what neuroplasticity is. Neuroplasticity is the ability for these connections in the brain and body to change in response to experience. And what's so incredible about the human nervous system in particular is that we can direct our own neural changes. We can decide that we want to change our brain. In other words, our brain can change itself and our nervous system can change itself. For a long time, it was thought that neuroplasticity was the unique gift of young animals and humans, that it could only occur when we're young. And in fact, the young brain is incredibly plastic. Children can learn 3 languages without an accent reflexively, whereas adults, it's very challenging. It takes a lot more effort and strain, a lot more of that duration path outcome kind of thinking in order to achieve those plastic changes. We now know, however, that the adult brain can change in response to experience. In order to understand that process, we really have to understand something that might at first seem totally divorced from neuroplasticity, but actually lies at the center of neuroplasticity. And for any of you that are interested in changing your nervous system so that something that you want can go from being very hard or seem almost impossible and out of reach to being very reflexive, this is especially important to pay attention to. Plasticity in the adult human nervous system is gated, meaning it is controlled by neuromodulators. These things that we talked about earlier, dopamine, serotonin, and one in particular called acetylcholine, are what open up plasticity. They literally unveil plasticity and allow brief periods of time in which whatever information, whatever thing we're sensing or perceiving or thinking, or whatever emotions we feel, can literally be mapped in the brain such that later it will become much easier for us to experience and feel that thing. Now, this has a dark side and a positive side. The dark side is it's actually very easy to get neuroplasticity as an adult through traumatic or terrible or challenging experiences. But the important question is to say, why is that? And the reason that's the case is because when something very bad happens, there's the release of 2 sets of neuromodulators in the brain, epinephrine, which tends to make us feel alert and agitated, which is associated with most bad circumstances, and acetylcholine, which tends to create a even more intense and focused perceptual spotlight. Remember earlier we were talking about perception and how it's kind of like a spotlight. Acetylcholine makes that light particularly bright and particularly restricted to one region of our experience. And it does that by making certain neurons in our brain and body active much more than all the rest. So acetylcholine is sort of like a highlighter marker upon which neuroplasticity then comes in later and says, wait, which neurons were active in this particularly alerting phase of whatever day or night, whenever this thing happened to happen. So the way it works is this. You can think of epinephrine as creating this alertness and this kind of unbelievable level of increased attention compared to what you were experiencing before. And you can think of acetylcholine as being the molecule that highlights whatever it happens during that period of heightened alertness. So just to be clear, it's epinephrine creates the alertness. That's coming from a subset of neurons in the brainstem, if you're interested. And acetylcholine, coming from an area of the forebrain, is tagging or marking the neurons that are particularly active during this heightened level of alertness. Now that marks the cells, the neurons, and the synapses for strengthening, for becoming more likely to be active in the future, even without us thinking about it, okay? So in bad circumstances, this all happens without us having to do much. When we want something to happen, however, we want to learn a new language, we want to learn a new skill, we want to become more motivated. What do we know for certain? We know that process of getting neuroplasticity so that we have more focus, more motivation, absolutely requires the release of epinephrine. We have to have alertness in order to have focus. And we have to have focus in order to direct those plastic changes to particular parts of our nervous system. Now, this has immense implications in thinking about the various tools, whether or not those are chemical tools or machine tools or just self-induced regimens of how long or how intensely you're going to focus in order to get neuroplasticity. But there's another side to it. The dirty secret of neuroplasticity is that no neuroplasticity occurs during the thing you're trying to learn, during the terrible event, during the great event, during the thing that you're really trying to shape and learn. Nothing is actually changing between the neurons that is going to last. All the neuroplasticity, the strengthening of the synapses, the addition in some cases of new nerve cells, or at least connections between nerve cells. All of that occurs at a very different phase of life, which is when we are in sleep and non-sleep deep rest. And so neuroplasticity, which is the kind of holy grail of human experience of, this is the new year and everyone's thinking New Year's resolutions. And right now, perhaps everything's organized and people are highly motivated, but what happens in March or April or May? Well, that all depends on how much attention and focus one can continually bring to whatever it is they're trying to learn. So much so that agitation and a feeling of strain are actually required for this process of neuroplasticity to get triggered. But the actual rewiring occurs during periods of sleep and non-sleep deep rest. There's a study published last year that's particularly relevant here that I want to share. It was not done by my laboratory, that showed that 20 minutes of deep rest, this is not deep sleep, but essentially doing something very hard and very intense and then taking 20 minutes immediately afterwards, to deliberately turn off the deliberate focused thinking and engagement actually accelerated neuroplasticity. There's another study that's just incredible, and we're going to go into this in a future episode of the podcast not too long from now, that showed that if people are learning a particular skill, it could be a language skill or a motor skill, and they hear a tone just playing in the background. The tone is playing periodically in the background, like just a bell. In deep sleep, if that bell is played, learning is much faster for the thing that they were learning while they were awake. It somehow cues the nervous system in sleep. It doesn't even have to be in dreaming, that something that happened in the waking phase was especially important, so much so that bell is sort of a Pavlovian cue. It's sort of a reminder to the sleeping brain, oh, you need to remember what it is that you were learning at that particular time of day. And the learning rates and the rates of retention, meaning how much people can remember from the thing they learned, are significantly higher under those conditions. So I'm going to talk about how to apply all this knowledge in a little bit more in this podcast episode, but also in future episodes. But it really speaks to the really key importance of sleep and focus, these two opposite ends of our attentional state. When we're in sleep, these DPOs, duration, path, and outcome analysis, are impossible. We just can't do that. We are only in relation to what's happening inside of us. So sleep is key. Also key are periods of non-sleep deep rest where we're turning off our analysis of duration, path, and outcome, in particular for the thing that we were just trying to learn. And we're in this kind of liminal state where our attention is kind of drifting all over. It turns out that's very important for the consolidation, for the changes between the nerve cells that will allow what we were trying to learn to go from being deliberate and hard and stressful and a strain to easy and reflexive. This also points to how different people, including many modern clinicians, are thinking about how to prevent bad circumstances, traumas, from routing their way into our nervous system permanently. It says that you might want to interfere with certain aspects of brain states that are away from the bad thing that happened, the brain states that happen the next day or the next month or the next year. And also I want to be aware, I want to make sure that I pay attention to the fact that for many of you, you're thinking about neuroplasticity not just in changing your nervous system to add something new, but to also get rid of things that you don't like, right? That you want to forget bad experiences, or at least remove the emotional contingency of a bad relationship, or a bad relationship to something or some person or some event. Learning to fear certain things less, to eliminate a phobia, to erase a trauma. The memories themselves don't get erased. I'm sorry to say that the memories don't themselves get erased, but the emotional load of memories can be reduced. And there are a number of different ways that can happen, but they all require this thing that we're calling neuroplasticity. We're going to have a large number of discussions about neuroplasticity in depth, but the most important thing to understand is that it is indeed a two-phase process. What governs the transition between alert and focused and these deep rest and deep sleep states is a system in our brain and body, a certain aspect of the nervous system called the autonomic nervous system. And it is immensely important to understand how this autonomic nervous system works. it has names like the sympathetic nervous system and parasympathetic nervous system, which frankly are complicated names because they're a little bit misleading. Sympathetic is the one that's associated with more alertness. Parasympathetic is the one that's associated with more calmness. And it gets really misleading because the sympathetic nervous system sounds like sympathy, and then people think it's related to calm. I'm going to call it the alertness system and the calmness system, because even though sympathetic and parasympathetic are sometimes used, people really get confused. So the way to think about the autonomic nervous system, and the reason it's important for every aspect of your life, but in particular for neuroplasticity and engaging in these focus states and then these defocus states, is that it works sort of like a seesaw. Every 24 hours, we're all familiar with the fact that when we wake up in the morning, we might be a little bit groggy, but then generally we're more alert. And then as evening comes around, we tend to become a little more relaxed and sleepy. And eventually, at some point at night, we go to sleep. So we go from alert to deeply calm. And as we do that, we go from an ability to engage in these very focused duration path outcome types of analyses to states in sleep that are completely divorced from duration path and outcome, in which everything is completely random and untethered in terms of our sensations, perceptions, and feelings and so forth. So every 24 hours, we have a phase of our day that is optimal for thinking and focusing and learning and neuroplasticity and doing all sorts of things. We have energy as well. And at another phase of our day, we're tired and we have no ability to focus. We have no ability to engage in duration path outcome types of analyses. And it's interesting that both phases are important for shaping our nervous system in the ways that we want. So if we want to engage neuroplasticity and we want to get the most out of our nervous system, we each have to master both the transition between wakefulness and sleep and the transition between sleep and wakefulness. Now, so much has been made of the importance of sleep, and it is critically important for wound healing, for learning, as I just mentioned, for consolidating learning, for all aspects of our immune system. It is the one period of time in which we're not doing these duration path and outcomes types of analyses, and it is critically important to all aspects of our health, including our longevity. Much less has been made, however, of how to get better at sleeping, how to get better at the process that involves falling asleep, staying asleep, and accessing these states of mind and body that involve total paralysis. Most people don't know this, but you're actually paralyzed during much of your sleep so that you can't act out your dreams, presumably. But also where your brain is in a total idle state where it's not controlling anything. It's just left to kind of free run. And there are certain things that we can all do in order to master that transition, in order to get better at sleeping. And it involves much more than just how much we sleep. We're all being told, of course, that we need to sleep more, but there's also the issue of sleep quality, accessing those deep states of non-DPO thinking, accessing the right timing of sleep. Not a lot has been discussed publicly, as far as I'm aware, of when to time your sleep. I think we all can appreciate that sleeping for half an hour throughout the day, so that you get a total of 8 hours of sleep every 24-hour cycle, is probably very different and not optimal compared to a solid block of 8 hours of sleep. Although there are people that have tried this. I think it's been written about in various books. Not many people can stick to that schedule. Incidentally, I think it's called the Huberman schedule, not to be confused with the Huberman schedule, because first of all, my schedule doesn't look anything like that. And second of all, I would never attempt such a sleeping regime. The other thing that is really important to understand is that we have not explored as a culture the rhythms that occur in our waking states. So much has been focused on the value of sleep and the importance of sleep, which is great. But I don't think that most people are paying attention to what's happening in their waking states and when their brain is optimized for focus, when their brain is optimized for these DPOs, these duration path outcome types of engagements for learning and for changing, and when their brain is probably better suited for more reflexive thinking and behaviors. And it turns out that there's a vast amount of scientific data which points to the existence of what are called ultradian rhythms. You may have heard of circadian rhythms. Circadian means circa, about a day, so it's 24-hour rhythms because the Earth spins once every 24 hours. Ultradian rhythms occur throughout the day, and they require less time. They're shorter. The most important ultradian rhythm, for sake of this discussion, is the 90-minute rhythm that we're going through all the time in our ability to attend and focus. And in sleep, our sleep is broken up into 90-minute segments. Early in the night, we have more phase 1 and phase 2 lighter sleep, and then we go into our deeper phase 3 and phase 4 sleep, and then we return to phase 1, 2, 3, 4. So all night, you're going through these ultradian rhythms of stage 1, 2, 3, 4, 1, 2, 3, 4. It's repeating. Most people perhaps know that, maybe they don't, but when you wake up in the morning, these ultradian rhythms continue. And it turns out that we are optimized for focus and attention within these 90-minute cycles, so that at the beginning of one of these 90-minute cycles, maybe you sit down to learn something new or to engage in some new challenging behavior. For the first 5 or 10 minutes of one of those cycles, it's well known that the brain and the neural circuits and the neuromodulators are not going to be optimally tuned to whatever it is you're trying to do. But as you drop deeper into that 90-minute cycle, your ability to focus and to engage in this DPO process and to direct neural plasticity and to learn is actually much greater. And then you eventually pop out of that at the end of the 90-minute cycle. So these cycles are occurring in sleep and these cycles are occurring in wakefulness. And all of those are governed by this seesaw of alertness to calmness that we call the autonomic nervous system. So if you want to master and control your nervous system, regardless of what tool you reach to, whether or not it's a pharmacologic tool or whether or not it's a behavioral tool or whether or not it's a brain-machine interface tool, it's vitally important to understand that your entire existence is occurring in these 90-minute cycles, whether or not you're asleep or awake. And so you really need to learn how to wedge into those 90-minute cycles. And for instance, it would be completely crazy and counterproductive to try and just learn information while in deep sleep by listening to that information, because you're not able to access it. It would be perfectly good, however, to engage in a focused bout of learning each day. And now we know how long that focused bout of learning should be. It should be at least one 90-minute cycle. And the expectation should be that the early phase of that cycle is going to be challenging. It's going to hurt. It's not going to feel natural. It's not going to feel like flow. But that you can learn, and the circuits of your brain that are involved in focus and motivation can learn to drop into a mode of more focus, get more neural plasticity, in other words, by engaging these ultradian cycles at the appropriate times of day. For instance, some people are very good learners early in the day and not so good in the afternoon. So you can start to explore this process even without any information about the underlying neurochemicals by simply paying attention, not just to when you go to sleep and when you wake up each morning, how deep or how shallow your sleep felt to you subjectively, but also throughout the day when your brain tends to be most anxious, because it turns out that has a correlate related to perception that we will talk about. You can ask yourself, when are you most focused? When are you least anxious? When do you feel most motivated? When do you feel least motivated? By understanding how the different aspects of your perception, sensation, feeling, thought, and actions tend to want to be engaged or not want to be engaged, you develop a very good window into what's going to be required to shift your ability to focus or shift your ability to engage in creative type thinking at different times of day, should you choose. And so that's where we're heading going forward. It all starts with mastering this seesaw that is the autonomic nervous system, that at a coarse level is a transition between wakefulness and sleep. But at a finer level, and just as important, are the various cycles, these ultradian 90-minute cycles that govern our life all the time, 24 hours a day, every day of our life. And so we're going to talk about how you can take control of the autonomic nervous system so that you can better access neural plasticity, better access sleep, even take advantage of the phase that is the transition between sleep and waking to access things like creativity and so forth. All based on studies that have been published over the last 100 years, mainly within the last 10 years, and some that are very, very new, and that point to the use of specific tools that will allow you to get the most out of your nervous system. So today we covered a lot of information. It was sort of a whirlwind tour of everything from neurons and synapses to neural plasticity in the autonomic nervous system. We will revisit a lot of these themes going forward. So if all of that didn't sink in one pass, please don't worry. We will come back to these themes over and over again.